Hey guys, so today I'm going to tell you the content that I have to learn in Extension 1 Maths. And yeah, I know if I just say Extension 1 Maths, you don't know what level of math I'm talking about. Alright, I'm talking about Year 12, New South Wales, Australia, Maths. There's a class called Extension 1 Maths in New South Wales, Australia, and it's the second hardest level. It's pretty hard. Like, it's really hard. The level just below Extension 1 Maths is called 2-unit maths, yeah. The reason why it's called 2-unit maths is because there's another name for Extension 1 Maths, and the other name is 3-unit maths, because Extension 1 Maths is another because 2-unit maths is counted as 2 units in the Australian HSC program, and Extension 1 Maths is considered 3 units, but they just call it Extension 1 Maths because it's seen as an extension of maths, and it's the first extension. The highest class is Extension 2 Maths, which is also known as 4-unit maths. But anyways, right now I'm gonna tell you the first things that I learned in the new syllabus. This is the syllabus 2020 of Extension 1 Maths. It can change for your school, but one thing that you can note is that the stuff that I'm telling you is the stuff that you are going to learn. So, in the new syllabus, for Extension 1 Maths, the first thing that I learnt about was pretty much trigonometry. Yeah? But it's not the normal kind of trigonometry. It's the trigonometry where you have to solve for the angle. You have to solve for the angle. Oh my god, I can't spell. Or it's the trigonometry where you have to prove that that you have to do a proof. But it's not. But the thing is, in trigonometry, most proofs, like the most basic proofs that prove the formulas, they're the ones that you don't, that's already given to you, that you have to know off by heart. Another word for that is memorize, but not really memorize, like practice to understand it. Practice the proof to understand it. But these proofs are absolutely random. They can just give you anything. So, I'm gonna write trigonometry proofs, example, question, and hopefully it talks about the things that I actually want. Oh yeah, this proving trigonometric identities. Alright, this is only for formulas. I'm talking about the questions that they give us. Okay. So over here. Oh yeah. I'm talking about these kind of questions over here. Question number, so apparently this question is question number 5. It says, prove the following identities where the angles involved are acute angles, for which the expressions are defined. Yeah, you see the square root of 1 plus sine A over 1 minus sine A is equal to sec A plus tan. Basically, what happens is that you have to get the left hand side to equal the right hand side, and you basically have to use what the rule, like, you have to simplify it somehow. Yeah, it's really hard. basically the only way to get around this is through practicing. If you don't do any practice, you're screwed, basically. You don't know. That's what happened to me in my exam. I was screwed. Alright, now let me search up a very, very important example. Oh my god. Okay, trigonometric proofs question, double angle formula in sine 3x. Alright, I can't really find it here. Alright, here. This is a really, really, really important question. If you're given something like sine 3x, you have to break it down to be the double angle formula plus another angle, but you don't know how to do that. You have to, the thing is, if you do this, 2 theta plus theta, yeah, the first thing that you assume is that you use the double angle formula, because there's a formula called double angle formula, and what it does is that it means that if you see anything with sine to theta, you use 2 sine theta cos theta. But in this case you can't, because there's a theta in the angle. So you kind of think of it in the form sine A plus B. And what you do there is that you use the formula sine A plus B is equal to sine A cos B plus cos A sine B. And you kind of substitute 2 theta into the angle A, and you substitute theta into the angle B, because it's from the formula sine A plus B, and 2 thetas in the place where A is meant to be, and theta is where the place where B is. So you just substitute it into the other side of the formula, which results in sine 2 theta cos theta plus cos theta sine theta. So yeah, this question over here is really, really, really important. If you don't know how to do this, you're gonna lose so many marks. It's a really, really important question. I wish someone tutored me this, because I don't have any experience with these stuff that they teach me at school. Alright, we finished with the most important parts of this. It's either, for the trigonometric proof questions, the hardest ones are the ones where you have to find the angle, but finding the angle of something is easier than doing the trigonometry proofs. The next thing that you have to learn, that I learned, was something called vectors in oh my god, I can't spell it. Vectors in maths. Alright, there's this rule in maths called head to tail in maths and physics. And apparently for my country, it's extension 1 maths. There's this rule, and it's called head to tail rule. It's either, if you're using head to tail rule, I will explain in my other video. It's either that you memorize all of these triangles, or it's either that you memorize all of these triangles, or it's either that you just use head to tail rule, but you use this very, very, very special method to be able to tell if something is if something is b minus a or a minus b. And if you use that method, you're never wrong. If you memorize this, I think you're 50% wrong because the hours can just be inwards and you just don't know what to do. So yeah. The head to tail rule is the best because it's always consistent. In vectors, I'll try to explain this in my other video, but there's also a rule called the parallelogram rule. But let me go to the triangle rule first. You see these 3 triangles? They're called the triangle rule. Basically, what it means is that if there's a vector that's head to tail, so it goes from the direction from A to B in that direction, it will become A plus B in that order because the arrow is showing that the direction is coming from A and then it's going towards B and it goes to the direction of where B is heading. Yeah? If this happens, that means that the resulting side that forms the triangle is A plus B, but it has to be in the order where it comes from A to B, in that direction. So from point A, where the A vector is, to the B vector, and that will become, in that direction, it will become A plus B. Yeah, the same thing goes for the parallelogram, but the parallelogram is just used so that sometimes if there's like a line and it's not head to tail, you use a parallelogram because the opposite side may actually be head to tail. That's why it's kind of hard to explain. I have to show you an example for you to understand. Yeah. There's more, but I'll try to explain it in my vector only video. So yeah, that's the summary of what I learned, but I'll try to explain things to you later. So goodbye.